Kosmos 482 was launched in 1972. It was intended to be a part of the Soviet Union's Venera program. The spacecraft carried a sophisticated suite of instruments. It was designed to study the atmosphere and surface of Venus. However, fate had other plans for Kosmos 482. A malfunction during launch prevented it from reaching its intended destination. The launch vehicle's upper stage failed to separate from the spacecraft. This left Kosmos 482 stranded in an elliptical Earth orbit. The spacecraft was never able to escape Earth's gravitational pull. It has remained in orbit ever since, a silent sentinel to a mission unfulfilled. Despite its failure to reach Venus, Kosmos 482 became an object of scientific interest. Its prolonged stay in space provided a unique opportunity. Scientists could study the long-term effects of the space environment on spacecraft materials and components. This information is crucial for designing future missions. We can make sure they can withstand the rigors of space travel. However, Kosmos 482's presence in Earth orbit also raised concerns. The spacecraft poses a potential hazard. It could eventually re-enter Earth's atmosphere in an uncontrolled manner. This could result in debris falling to the ground, potentially causing damage. Kosmos 482 is just one of thousands of pieces of space debris orbiting our planet. Space debris, or space junk, is any human-made object in orbit around Earth that is no longer functional. This debris ranges in size from tiny flecks of paint to defunct satellites and spent rocket stages. The increasing amount of space debris poses a significant threat to our spacefaring future. Collisions between objects in orbit can create a cascade effect. This is known as the Kessler syndrome. Even small pieces of debris can cause significant damage when they collide with operational satellites or spacecraft at high speeds. The international community recognizes the seriousness of the space debris problem. Efforts are underway to mitigate the risks. These efforts include developing guidelines for responsible space operations. We also need to design spacecraft for easier disposal. And we must research technologies for removing existing debris from orbit. Tracking space debris is crucial. We need to understand and predict its movement. This allows us to avoid collisions and protect operational spacecraft. Ground-based radar and telescopes play a vital role in monitoring larger objects. Space-based sensors and data analysis techniques are also being developed. We can improve our ability to track even the smallest pieces of debris. As we venture further into the cosmos, the importance of responsible space exploration becomes ever more apparent. The case of Kosmos 482 serves as a poignant reminder of the challenges and risks associated with our endeavors in space. The uncontrolled re-entry of Kosmos 482, while carrying a low probability of causing damage, highlights the need for careful planning and consideration of the long-term consequences of our actions in space. Every mission launched into space must be designed and operated with a focus on minimizing the creation of new debris. We must also prioritize the development and implementation of technologies and strategies for removing existing debris. International cooperation is essential in addressing the challenge of space debris. By working together, we can develop comprehensive international guidelines and treaties. These will ensure the responsible use and long-term sustainability of space for all. The exploration of space is a testament to human ingenuity and our insatiable thirst for knowledge. However, as we reach for the stars, we must do so responsibly and with a keen awareness of our impact on the space environment. The future of space exploration, and indeed our own safety and security here on Earth, depend on it.